There you are now. Welcome back to the workshop. On today's episode, we're going to take a look at putting a bonnet onto this Clubman estate. There's a few things we have to think about when we're putting a bonnet on a... No, we have to think about switching our phone off. Who is that? Oh, it's Keith from Classic Mini Workshop. We'll see what Keith has to say. Hello. Keith, how are you? That's good to hear. Okay. Yeah, tracking notice. Yeah, no, that's my address. All right, we'll take a look out and see if we can see it. I'm looking out the garage door now, I don't really see it. All righty. Look, Keith, I'm gonna have to buzz on here. I'm shooting the intro to a video. Oh, it seems like we're doing this to each other all the time. Go on, I'll talk to you. Bye, bye. That was Keith from Classic Mini Workshop. Keith's a great guy. He actually just put up a video recently of a collaboration we're doing on some wheel nuts. Keith has a great channel. I'm going to link it in the description down below. He has loads and loads of really brilliant videos. Keith's a real interesting guy to listen to and has really spent a lot of time making his videos, guys, and really making them easy to understand, and tackles everyday stuff that you would be dealing with all the time on a car. So if you like what you see on my channel, you're going to love what Keith produces. So maybe click the link down below and head over to his channel. Maybe put in the comments, popped over from HREIRL, and give us an L mention over there. Keith would be delighted. All right, we'll get back to doing... What the bloody hell is that? How in God's name am I supposed to get that back? Well, that was unexpected. If it's all the same, I might just post the wheel nuts back to you. 12 hours later and I am still wrecked after that. Come on, we play with your nuts, Keith. So Keith has a problem that I spotted, and basically, well, he knew this problem was there, but I think I've figured out a solution for it. So basically, Keith has Hillman Imp wheels that he's fitting to the Mini, and one of the things about Keith's wheels is that there is a convex embossment in the wheel that the wheel nut is supposed to sit in and centralize the wheel. Now, Keith found these washers which have that exact convex shape in them. The only problem is, well, I suppose the wheel is concave and the wheel nut is supposed to be convex, and the two of them line up together to centralize the wheel nut in the wheel. The problem is that the hubcaps he wants to run with this wheel need a very specific wheel nut. It's a wheel nut that looks like this and has a plastic locking washer on it, and then a plastic cap pops over that and sits in this detail here. So that sort of little detail or little indentation in the wheel nut is what holds on these kind of plastic caps afterwards. Keith came up with a bit of a solution to this. He used the taper wheel nut first to centralize the wheel on two of the studs, and then he put a washer on and this wheel nut behind it on two of the other studs, and then took the taper wheel nuts off and put this on. Anyway, I watched the video and I was like, this is a total faff. And we went back and forward a few times. We started off with me making him a custom wheel nut that would specifically have this sort of taper on one end and would have you know, all these details and features on the other end. We got to thinking about it, and we got to the stage where that would be an extraordinary complex bit of engineering, and while it is achievable, it just seemed like it was a long way around. A little moment of inspiration came to me, and I thought, well, actually maybe I could just centralize this washer on this wheel nut and then weld it. So I could run a TIG weld bead around here, and then a little bit of refinishing afterwards on the lathe, and we would have a completely centralized stud and washer. So how I'm going to achieve that is I'm going to make up a mandrel for the welding. Okay, so I have, this is the same thread, so that's actually a head stud out of a Mini, right? That's a head stud, but the head stud has on the end of it here 3/8 UNF, which is exactly the same as what's or what a Mini wheel stud is. It's exactly the same. The reason I'm using this as opposed to a wheel stud is it's just a straight shank. So what my plan is I'm going to run 2 of these nuts down on to the end of the head stud like that, and I'm going to lock one against the other onto the stud so that I know that I have a solid piece of metal locked onto the stud. And then I'm going to put this whole thing in the lathe, and I'm going to turn a detail on here whereby this washer sits dead center on the stud. So basically we'll be able to put the washer down and it'll sit on a detail here that will have the exact same dimensions. So you can see the play that's in there. Yeah, the way that's moving around. That was Keith's problem. That was causing the wheel to go out of alignment when you put these washers on. So what we actually need is we need that washer to be right in the center of the stud. So we'll do that by turning a profile in here onto the end of this nut that washer will sit on. Then we can simply just wind the wheel nut down onto the washer like that, and it'll sit in the center. Then we can run a TIG weld bead around that, and then the 2 pieces will come off as one, and we know that the washer will be dead center with the wheel nut. Okay, and then that will mean if we do that times 16, Keith will have a 1 unit that he can just literally screw his wheel on, and it will centralize his wheel, hold his hubcap, and give him a place for his finishing to go. So the first thing we need to do is we need to head over to the lathe, and we need to turn a feature on this that will support that washer dead center on that stud. Go to the lathe. So we're set up over here at the lathe now, and let's just see what we need to turn on this feature. So if we measure this internal diameter, it comes out there at sort of 10.5 millimeters, give or take. Now we know that the end of the stud here, that I just have a wheel nut screwed on here, but we know that the end of the stud is 3/8 UNF. So 3/8 UNF is around 9.2 millimeters. So we have over a millimeter to make up. So what I've done is I've set up the end of the wheel stud in a collet chuck here, and I'm just checking the run out here on the dial. So you know, we have 0 there, and then our high spot, see if I can get you just a slightly better angle. Sorry, let me just see if I just re-engineer this for you. Okay, so let's find our high spot. We'll get to our 0 here, and let's see where our high is. So 0.1, just 0.2 of run out. Now that's the run out in the stud because we're in a collet here. So we can't have any run out there in the collet. So the run out we're seeing here, 0.2, is in the stud. 0.2 is fine for a wheel. We're happy enough at 0.2 for a wheel. So we'll start turning this profile. So first of all, what we need to do is we need to just get the flanks off this nut till we get down to a round diameter. And then what we'll do is we'll creep up on the measurement. So just to show you that there, if I come in on the wheel stud, what have we got? 9.29. That's kind of what I said. And we know the inside diameter of the washer is 10.5. So we have about a mil or just over a mil in the difference between the two is what's going to end up being our size. So what we'll do is we'll touch off on the nut and then we'll take a couple of passes. We only need the shoulder that we're turning here to be just about the size of this wheel nut, or sorry, of this washer. So we know that's 4 mil. So we really want a 3.5 mil shoulder because we want a little bit of clearance there. So we need to come back about 3.5 mil. So we'll just touch off here. And we'll take our first pass at 0.1. Now we can always just fettle this shoulder afterwards if we need it a bit deeper or a bit shallower. So you can see there now we had a fairly consistent chip, which is telling us we're now in a round profile anyway. We're getting a little bit of chatter there. So that little bit of chatter we're getting there is just because we've got a good bit of stick out here in the lathe, but we don't have really much of a choice. So what are we at now? We're at 12.8. So we have another . So we did a 1 mil pass there, yeah, 11.8, and we know that the measurement we actually want is 10.5. So we'll do another half mil pass. We're going to hand feed this last bit in here. So we're just going to creep up on it now. Two. Very close now to our measurement. Yeah, that just about wants to fit. What are we at there now? Yeah, we're at 10.9 now. Yeah. So another spring pass or two and we'll have what we want. So we want this to be we don't want this to be a friction fit, but we want it to be really tight. To come off. right there now. Okay, so that is just going on there now. We want just a tiny bit more clearance than that, so we'll bring the last bit of clearance in with the file. I always keep an old file over at the lathe just for this job, for just bringing in a bit of clearance. So on your file you've got a smooth side and you've got a rough side. You want to always make sure if you're using a file on the lathe that you bring the smooth side into the shoulder so it doesn't grab. So that's our fit there now. So what we now have is we have a situation where we can get our wheel nut now to just spin on there. And we know our wheel nut's on the center of the thread, and we know that this washer is on the center of the thread. So in this scenario now, we can weld our wheel nut to our washer, and then the whole lot can spin off as one piece then. And do that times 16, and your job's a good one, Keith. We'll go over now to the welding plant and we'll get set up for the weld. Okay, so I'm back over at the welding plant. You might think this here is a bit of a schmozzle, a bit of a setup. I have a rest over here to put my hand on. I have an old chuck off the lathe, and believe it or not, the differential housing of a Mini down here acting as the wheel bearing, as a bearing. At the end of the day, all I'm trying to achieve here is a setup that very quickly allows me to centrally weld this wheel nut to this washer. That's all we're trying to achieve. It's not complicated. I don't have a rotary welding positioner just sitting around to use like this because, well, rotary weld positioning is something I might do once in a blue moon. So this is the kind of out of the box type thinking that I like to do all the time here in my shop. Just quickly, proof of concept and idea, then run the job through the shop, and then you're over and done with. And this is a really good example of that. So I have my TIG plant set up here. I have a pedal down at my left foot, you can see over here, and that is how I trigger the torch. I have here set up a rest for my hand to sit on. With TIG welding, one of the most important things you can do is for your hand to be relaxed so that you can hold the torch in a manner that allows you to get in at the weld nice and tight. My other hand then is going to be down here nice and low, and it's going to allow me to move this wheel nut around on this little jig that I've made as I weld it, okay? So we'll do a couple of passes, we'll get a few of these welded, and then we might try and see can we get you in to look at the weld. So we'll see if we can put a lens over it. It may or may not work, so bear with us and we'll see what we can achieve. Okay, so we've got a bead of weld run all the way around the wheel nut now. It will need a little bit of refinishing in the lathe to just clip off all the high spots and bring the outside of the nut around. Obviously, as you run the weld around, you get a little bit of undercutting, well, not undercutting, but it'll knock the sharp edge off the side of the washer. Perfectly fine. We've measured what we need, and we know that this washer needs to be around 10 millimeters, or sorry, it needs to be around 20 millimeters on the external diameter. When they came to us, they were 22, so we know we've 1.5 mils to play with, or even 2 mils to play with, just to bring them down into size. So that's basically the process. I have to repeat this now 16 times, and I'll have a bunch of wheel nuts for Keith. Then we can go to the lathe and we can do a process there. I'll do another few shots of the welding for you, and then I'm not going to hold you to watching me weld 16 of these together. We'll move on then and show you what the next step in the process is after that. So after we completed the welding on the nuts, what we have now is a kind of a rough surface. You can see the OD here is rough surface. It's kind of undercut a little bit and just not really very nice. So we want to finish that up in the lathe now, just to make it nice and concentric and looking nice. Now, I had a good chat with Keith about this, and what he said to me was that the OD of these washers is like, well, we'll get a mic now and just see what they are. I think he said the OD was, you know, north of 20. Yeah, it's 21. And I think we said we were happy to go down as far as even 19 to bring it up right, because he checked on the flange of the wheel and they're around, or the embossment in the wheel is around 19 millimeters. So we were happy enough to bring it down to 19. So what we'll do is we'll just take a couple of passes here just to clean it up. Now, kind of have to take these passes very light because this is welded stainless steel, so it's hard material. So just a couple of light passes just to bring it up, and I think we're going to finish them all in at around, let's see now, I think we'll get around 19 maybe. Let's see what dimension we get there. So yeah, I think we'll shoot for 19. That's 19.8. So I think we'll shoot for 19, and that'll clean up perfectly at 19. 1. That's grand. Take a 1mm pass. And yeah, that is cleaning up pretty much perfectly there now. You can hear the cut is on the money. So the next thing we want to do is just a little bit of Scotch-Brite just to break those edges. Clean up that mating surface. And the last thing we'll do now is we'll go over to the wire wheel and we'll give this a run on the wire wheel. So I'm pretty happy with that. Okay, so that's kind of our finished nut. We've turned our OD. We have just wire wheeled it just to get any kind of dirt that might be off it. And you can see we're in there where we need to be. Now there is a tiny little bit of undercutting on these welds. You can kind of just see it here in the root. There's a little bit of undercut. I'm not worried about that because the wall thickness of this is really heavy and the actual job of this weld is not structural at all. You can see the thread on this wheel nut comes all the way out to the end. So the portion that will hold the wheel on will actually be up here. It's the threads up here that are going to hold the wheel on. So this undercutting down here, while for a weld would normally not be a good situation to have, I actually did undercut it on purpose because I wanted the weld to run in on top of the washer. I didn't want the weld peening off the edge of this washer because it's very important that we get as much surface area on that washer as we can, and we know the edges are very, very thin. So letting it undercut a little bit in there, while for a weld normally wouldn't be a good sign, you'd want to run filler rod in to bring that undercut out. The purpose of this weld is nothing other than to hold this washer central in the wheel nut, so it's perfectly fine. It's exactly where we want. The nice thing as well is that we don't see any colour changes gone up the nut, so we don't see any major colour changes in the steel, which means we haven't affected the hardness of the steel or hardened it. I let these cool down normally after I welded them, so I left them just sit there on the end of the stud, each one for a couple of minutes until they were cool enough that I could touch, which means they would have normalized as opposed to kind of quenching them, which could brittleize them or harden them or anything like that. So we let them come back down to room temperature nice and normally. I hope you enjoyed following us for that little job for Keith. We have a few more to wire wheel now and we get them in an envelope. And yeah, like I said, I think we might post them back to you, Keith. It'll be a bit more easy. I hope you enjoyed the video, guys, and if you did, don't forget to give us a like. If you're new to the channel, you are very, very welcome. We're delighted to have you here in the shop with us. If you've come over from Keith's channel, we really appreciate it. Have a look around, see some of our other videos. Hopefully you enjoyed them and there's something in the channel for you that you can find and enjoy. Other than that, as I said, if you're new to the channel, I hope we've earned a subscribe. If so, you know, bang that old subscribe and you'll get to see any of our new videos as we release them. We release kind of 2 videos every week of some shape or form. And after that, I'll see you guys on the next one.